All right, here we go. We are continuing for like it seems like the 10th time. Actually, I don't want to do that. What did I want to write on here? I wanted to write section 13.7. That's what I wanted. Oops. All right, this is part like 27 or something. It seems like, okay, but it's a lot of stuff packed into this lesson. It really is. And remember, the first couple videos we were kind of backtracking a little bit on 13.6. So really, it said 13.7, but some of this stuff we probably should have covered in 13.6. So anyway, this is hopefully the last one that we do today. So what we're going to do today is talk about the inverse functions. We already know what the regular trig functions look like. We know what the cosine looks like. We know what the sine looks like. And we know what the tangent looks like. So now what we're going to do is we're going to do the inverse functions of those. So what I've done right here is I've put the sine and cosine, and I've put the inverses. Now in this particular program, if you look right here, it says 1 over the sine. What's 1 over the sine? What's the inverse of the sine? What's the trig function called? The inverse of the sine. What's that? Secant? James? Yeah. 1 over the sine? It's the cosecant. It's the cosecant. Remember, it's a different letter. So sine and secant aren't inverses of each other. It's the sine and the cosecant. And the inverse of the cosine is the secant. And the easiest one is the tangent. What's the inverse of the tangent? Cotangent. Okay. So let's do, which one do you want to do? Cosine or sine? Doesn't matter. Cosine? Okay. That's what the other class picked. I can click on there. Okay. Oh, wait a minute. I didn't want to show that. I gave it away. I wanted the regular cosine. Sorry about that. Now all the fun's taken out of it, isn't it? So what we're going to do here is I want to find the inverse of the cosine. All right, which this is the cosine right here. I want to find the inverse of it. So what I'm going to do is I'm going to draw a little x and y chart. Oh, actually, I'm going to actually put two things here, 3 columns. First one is theta. The next one is the cosine. I want you to see the relationship between the cosine of the angle and the secant of the angle. All right. Now remember what the secant is. The secant is just the what? Inverse of the cosine. So what's the inverse of anything? What's the inverse of a half?
2.
It's 2. What's the inverse of 2/3? 3 halves. Okay, so that's what we're going to do. We're going to figure out, we're going to put some angles down here. We know the cosines already. We should know them already. What we're going to do is do the inverse, find out what the secant is, and see what our graph looks like. Is that all right? So let's do some points. Let's start at 0. Let's just stay in the first quadrant, make it a little easier for us. So let's go 0, 30, 45, 60, and 90. All right. From there, if we do all the angles in the first quadrant, that'll give us a general idea of what we do in the other quadrants as well. All right. It'll just be too time-consuming to go through every single angle. So we're just going to do the first quadrant and see what happens. Now, if you remember, you should be able to do the cosines in your head. Remember that? So what's our ordered pair? So let's put some ordered pairs here just so we can visualize it. So that's 1, 0. So yeah, say it, James, the cosine of 0 is 1. You can just look at this, right? Because the cosine is the first part of that ordered pair. It's the x. The sine of the angle would be 0. But we're doing cosine, aren't we? Okay, we're just trying to graph. We have a cosine curve right here. We just want to figure out how we got that cosine curve. Then we'll figure out how we get the secant curve. James? Sure? Okay. Now, what's the inverse? Remember, the secant is the inverse of the cosine, isn't it? So let's take the inverse of this. What's the inverse of 1?
1.
It's just 1. All right, because 1 is 1 over 1. What's the flip it? It's still 1 over 1, isn't it? All right, so that's the easy inverse. What about 30 degrees? 30 degrees was like this, wasn't it? Which one's the cosine? Say it, Ryan. Right, square root of 3 over 2. Now, we're graphing it like right here, and we need numbers. You don't see a square root of 3 over 2 here on the y-axis, do you? So let's put it in a calculator. Ryan, what'd you get for square root of 3 over 2? Yeah, it's about 0.87. Okay, do this. Put, now, 30 is the square root of 3 over 2. That would be the cosine. What would be the secant then? It would be the inverse of this, which would be 2 over square root of 3. All right, I'm just interested in the decimal number right now. So what's 2 divided by the square root of 3? 1 point what? 1.5? Okay, 1 point, let's just say 2. We'll round it to the first decimal place, right? Because 15, 1.5, the 5 rounds that up to a 2. All right, well, I put a 5. I sure did. I was wondering why you gave him that look. Now I know why, because I put a 5. Right, 1.2, all right? What about 45? What's 45 degrees? It's square root of 2 over 2. Put that in the calculator. Square root of 2 over 2. I think it's like 0.71. Okay? Let's put, now again, that was square root of 2 over 2. The inverse of that would be 2 divided by the square root of 2. Put that in a calculator. 1.4. Okay. All right, you with me so far? All I'm doing is finding what the cosine was. We've already done that. And I'm just finding the inverse of it, right? Right? So that's 1.4. Just put it in the calculator. You could just take 0.71 and take the inverse of that as well. What about 60? 60 degrees is that steep one, and the cosine is that short side. Good. So you're getting that down now. So it's a half, or we're going to go decimal, so it's 0.5. Now, what's the inverse of a half? Yeah, you don't need a calculator for that one. It's just a 2. Okay. Now, here's the one where it gets a little weird. What about 90? What's the cosine? Here we are at 90 right here, and that ordered pair is 0, 1. What's the cosine? It's 0, isn't it? Now, what's the inverse of 0? That's kind of weird. Is it nothing? Yeah, it's undefined, isn't it? All right. So why? You could put 0 over anything. Let's just put it over 1. Let's just put it over 1. Okay. Would you agree?
Yeah.
All right. So what's the inverse of that? It's 1 over 0. What's anything? See what I said? And you could put this over any number. Yeah, anything divided by 0 is undefined, right? Or James likes to say the null set. He likes that word. Okay.
My cousin taking calculus
And he says you null set, yeah. Yeah, you can say that. Or empty set, it's the same thing. Or you can just say it's undefined. Any of those are proper, they're fine, no big deal. All right? Now, I'm just going to put a little dash through there. That's kind of what we did the other day with the tangent, isn't it? All right, so now it gives us an idea of how to graph this stuff. Now, what I'm going to do, I'm going to keep that little XY chart there. Let's get rid of this stuff. Wow, craziness in the hallway. Middle schoolers. Yeah. Just think a few years ago, you were there. All right, a couple years ago. All right, so here we go. Let's graph this thing. Now, if you look at this, let's see what the cosine. At 0 degrees, it's 1. So that's good, isn't it? Let's do the cosine, then we'll do the secant. At 30 degrees, it's 0.87. Does that look about 0.87? Sure it does, because that's close to 0.9. Yep, that looks pretty good. 45 degrees is halfway in between. What do we go? 0.71. Yeah, that's a little bit lower, so that looks good. 60 degrees is a half. Bang, right there at a half, isn't it? And at 90 degrees, where is that? That's at 0. So would you agree that follows where the point should be? Yep. Now, what we're going to do, tell you what, let's just get rid of those dots. I just did that so you could see that that was good on the cosine. Now, let's do the secant. The secant's a little weirder, okay? So let's put some points in there. What are we putting in? At 0 degrees, we're putting in a 1. Wow, just like the cosine. Same spot, isn't it? But that's about the only similarity, okay, between it. At 30 degrees, what are we going to go to? 1.2. So we're going to go about right there. Now I'm just kind of eyeballing, right? I don't see exactly where 1.2 is, but that's probably close. At 45 degrees, we put in 1.4. So 45 is halfway between there. 1.4, I'd say about right there. Okay, that's pretty close. 60 degrees, that's an easier one. That's 2, so I can go right on the dot right there. Now, I don't have anything between 60 and 90, do I? All right, let's just stick one in here. I don't know. Give me an angle somewhere between there. 80? 80 is good. He said 80 first. Punch in 80. Because I don't know what that is. That's not one of our, special angles. So what's the cosine of 80 degrees? Cosine of 80 degrees. 0.17? Okay. Now take the inverse of that. Do you know there's a button on your calculator that does inverse right away? There's a button on your calculator that says 1 over x. Did you know that? So if you put in cosine of 80, then hit this button right here, it'll take the inverse of it. So what's the inverse of whatever? What did I say that was? Point what? I can't even read my own writing.
0.17.
Oh, 0.17. Okay, and so what is this then? 5.76. Now watch. At 80 degrees is here. Look how much it goes up. It goes way up here. I don't even have 5 on my graph right here, do I? I mean, I could scoot it down, but that would mess everything up. So, but 5 would be like way up here. Do this, just for fun. Put in 89 degrees. All right, put in 89 degrees.
Inverse.
And do the inverse. So you're doing, do the cosine of 89. 57. Look, at 89, you got to go way, way up here to 57. All right. You could keep putting numbers in close as you want to 90, and it'll just keep going up and up and up and up. All All right, so put in like 89.999999, as many nines as you can fit in there.
What was the button you said to push?
This 1 over x, do you have that on there? I'm not sure where that is on the graphing calculator, but I know on the 30XA. Yeah, so it's like in the billions, is that what you said? Trillions, in the trillions. Isn't that crazy? 89.999. Guess what happens when you get to 90? Look, it's undefined. What do we do at 90? Yeah, and I'm going to go to the next video to put the dotted line, because we're about out of time on this one. Yeah.
I know that you only want to get a 90, but what would happen if you went to 91?
Oh.
Then it would be extremely low.